Friends, Saira, this is Megha Miss here, and today we will continue with our lesson number 13, carbon, an important element. Okay students, we started with the lesson. Last presentation you saw about importance of carbon. Yes, carbon is very important to the living world. Everywhere you can see carbon presence is there. Okay, then what you saw about? You saw about the properties of carbon, right? If you remember, its atomic number, its atomic mass, its valency. Okay, then we went through the allotropy concept, and we saw one of the allotrope, crystalline allotrope of the carbon. Okay, that was diamond. And then we saw about the graphite. Now the third one, students, today we are going to see, that is the fullerene. Okay, so the third one is the fullerene. Now fullerene, an allotrope of carbon, is rarely found in nature. Okay, it is found in soot and in interstellar space. The first example of fullerene is Buckminster fullerene C60. How many carbon atoms, students? 60 carbon atoms are attached together, and that structure we will call it as a fullerene. Okay. This allotrope of carbon is named fullerene after the architect Richard Buckminster Fuller. Okay, because the structure of C60 resembles the structure of the geodesic dome he designed. So he designed one dome, and this structure, it resembles to that. So after his name, this structure is given the name. Okay, Harold Kroto, Robert Kerr and Richard Smalley were given the Nobel Prize in Chemistry 1996 for the discovery of this carbon allotrope fullerene C60. Okay, so what is how many carbon atoms, students? There are going to be 60 carbon atoms. Okay, and that structure, that arrangement, we will call it as the fullerene. Okay, now C60, C70, C76, C82 and C86 are the other examples of fullerene. Okay, these are the some examples of fullerene. Their molecules occur in small numbers in soot. So very small numbers you will get it in the nature. Okay students, hardly you will find them in the nature, and these are all the different arrangements. Okay, the arrangement of 60 carbon atoms can be there, 76 can be there, 82 carbon atoms can be there, and 86. Okay, so we'll proceed. Now this is the structure of the fullerene. You can see buckyball, we can also say it as a buckyball, where 60 carbon atoms have been arranged. You can see how it is forming a ball. Okay, and these are the bucky tubes, which we called it as carbon nanotubes. We use it in nanotechnology, a new branch of science, where nanotechnology is now, means now it's a long back it has been introduced, but it's a new one, where the nano means very small structures are being studied. Okay, so carbon nanotubes, this is the structure of the carbon nanotubes, which you can see, which is now being utilized in various devices. Okay students, we'll proceed. The properties of fullerene. Now the first property of fullerene, molecules of fullerenes are found in the form of buckyballs and bucky tubes. Now only you saw carbon nanotubes, we call them. Okay, there are 30 to 900 carbon atoms in one molecule of a fullerene. So one molecule of fullerene, you can have 30 to 900 carbon atoms which are attached together. Okay, fullerenes are soluble in organic solvents such as carbon disulfide, chlorobenzene, etc. So they are dissolvable. Okay, but in some of the organic solvents. Okay students, I hope till here it is clear. Okay, should we proceed the next part? Now see here, what are the uses of fullerene? Fullerenes are used as insulators. Okay, so if they are used as an insulator, students, then are they a good conductor or a bad conductor of electricity? Yes, they are the bad conductor of electricity. Okay, fullerenes are used as a catalyst in water purification. You know what is a catalyst? Yes, where do we use catalyst? We use the catalyst to alter the rate of the reaction, to increase the rate of the reaction, right? Catalyst take part in the chemical reaction? No, it will not take part in the chemical reaction, but it will be present and it will help to increase the speed of the reaction, we can say. Okay, so fullerenes we can add to increase the speed of the reactions during the water purification process. Okay students, I hope till here it's clear. Third one, at a certain temperature, fullerene exhibits superconductivity. This is another branch of science which has been introduced, that is conductivity, superconductors. Okay, so at some temperature, fullerene can be used as a superconductors, which are the fastest medium to conduct the electricity. Okay students, I hope what is the fullerene. Okay, third crystalline form of the carbon. Then we have seen its properties and its uses. Okay, we'll proceed to the next part now, that is the B part, non-crystalline or amorphous form. Now we have seen the crystalline form. Now we will see the non-crystalline, or we will call it as the amorphous form. Okay, the arrangement of carbon atoms in this form is not regular. Now in crystalline we saw they have a regular shape. Yes, coal, coke are the non-crystalline forms of carbon. Okay students, remember coal and coke. Okay, first one we will see coal. Coal is a fossil fuel. Yes, you have studied this. It contains carbon, hydrogen and oxygen. It also contains nitrogen, phosphorus and sulfur. So in journal what it will contain? Carbon, hydrogen, oxygen, phosphorus and sulfur. Okay, it occurs in the solid state. It is of 4 types. Okay students, now we will see that 4 types in which coal is occurring in nature. Now the A type, first one is the peat. Okay, formation of peat is the first step in the formation of coal. Okay, first step will be formation of a peat. It contains a high proportion of water and less than 60% of carbon. So carbon percentage is less than 60% but high proportion of water. Therefore, not much heat can be obtained from peat. Okay, so much amount of heat. Coal for what we are using? For heat energy, na? So peat cannot give that much amount of heat energy. Okay, you can see the picture also of the peat, how it looks like a brick only. Okay. Now B part is the lignite. Peat was transferred, yes, into lignite due to increased pressure and temperature inside the earth. Okay, because of the increased pressure and temperature, peat got converted to lignite. It contains 60 to 70% of carbon. Lignite is the second step of the formation of the coal. Okay, so first step is peat, second step is the lignite. Can you see the picture of lignite? That peat is converted to lignite under the pressure and temperature. Okay, I hope till here these 2 parts are clear students. Okay, should we proceed? Okay, now C part is the bituminous coal. Now what is this students, bituminous coal? Bituminous coal was formed as the third step of the formation of the coal. Okay, what is the third step student? Formation of bituminous coal. It contains 70 to 90% of carbon. Is the proportion of carbon increasing? Yes. Right? In each and every step, the proportion of carbon is increasing. And yes, students, we are interested in carbon. Right? We are interested in the formation of the coal because it is going to give us the heat energy. Okay. So, next, after the bituminous coal, you can see the picture. We have the anthracite. Now, anthracite is known as the pure form of coal. Okay, this coal is hard and contains about 95% of carbon. You can see the picture of anthracite. Okay, same, both are looking same, but yes, the difference is there in percentage of carbon. Okay, bituminous coal will contain 70 to 90% carbon, while the anthracite will be the pure form of coal and it will be hard and it will contain 95% of carbon. Okay students, so 4 stages we have seen. First will be the peat, next will be the lignite, third one will be the bituminous coal, that is the third step coal, and the fourth one will be the anthracite. So you have to remember all these 4 steps students, and you have to remember the amount of coal which is present in all the 4 stages. Okay, I hope till here it is clear to you. Okay students, now we will proceed with the charcoal. Okay, now what is this students, charcoal? You have heard the word before also. The charcoal that is made from animals is made from their bones, horns, etc. On the other hand, the charcoal made from the plants is formed by combustion of wood, in an insufficient supply of air. You know this, students. Yes, what is a charcoal? It can be made by animals also, by plants also. If in case of animals, their bones and horns we are using to make the charcoal. In plants, what we are using? We are burning, combustion of wood we are doing in insufficient amount of air. Okay. Now what is the uses of coal? Coal is used as a fuel in factories and homes. Yes. Sometimes we use coal in our cooking also. Yes. Next, coal is used to obtain coke, coal gas and coal tar. So all these are used in the roads. Okay. Coal is used in thermal power plants for generation of electricity. Yes, as it is given lot of amount of heat. Charcoal is used in the purification of water and organic material. Okay, students. So charcoal we are using in the purification of water and as an organic material. Okay. I hope till here it's clear to you. Okay. These are all amorphous forms of carbon. Now third one is the coke. The pure coal that remains when coal gas has been taken away from coal is called the coke. So when you remove, okay, from the pure coal, when you remove the coal gas, whatever the gas is coming out, when you remove that gas, it is called as a coke. Okay. Now what are the uses of this coke? Used as a domestic fuel, we are using it as a fuel. Coke is used as a reducing agent. Okay. Coke is used in the production of aeriform fuel such as water gas, okay, CO plus H2, and producer gas, CO plus H2 plus CO2 plus N2. So this is the composition given of the producer gas and the water gas. Okay, student, these are the two types of gases. In their production, we are using the coke. Okay, you can see the non-crystalline form of carbon. I am showing you the picture of coke. Okay, all mostly look same only, but the difference is the percentage of coal and carbon present in them. Okay, I hope the amorphous forms are also clear to you. Okay, students, now we'll proceed the next part. We are going to see that is the hydrocarbons. Now what is the, students, hydrocarbons? They are the basic organic compounds. You know now from this organic word means carbon will be present in that substance. When carbon is present in any substance, we call them as organic in chemistry. Okay. Now first point we will see under that, along with carbon, the element hydrogen is also included in most organic compounds. So in organic compounds, we say, as I told you now, carbon will be there, then that compound is organic in chemistry. Okay. But along with this carbon, students, you are going to have the hydrogen. The compounds formed from only carbon and hydrogen are called basic organic compounds. They are also called as hydrocarbons. Hydro means hydrogen, carbon means carbon. So hydrocarbon means combination of hydrogen plus carbon. Okay. So the electronic configuration of carbon is 2, 4. You know this. Yes. If 4 electrons are added to the second orbit of carbon, its octet becomes complete and its electronic configuration becomes stable, like that of the nearest inert gas, neon, which is 2, 8. Okay. If in the last shell I add 4 electrons, 4 plus 4 will become 8. So 2, 8, right? Which is the electronic configuration of neon. So will it become stable carbon also by taking 4 electrons? Yes. Okay. Therefore we say that the valency of carbon is 4. However, this occurs by sharing of electron rather than give and take of electrons. But carbon, it does not take 4 electrons, neither it gives those 4 electrons which it has. What it will do? It will share the electrons. Okay. In other words, a carbon atom can form 4 covalent bonds. You know, sharing means which type of bond, students, will form? Covalent bonds. Okay. With other carbon atoms or atoms of different elements. So they can form the covalent bond with another carbon atoms also or any other elements also. Okay. When a carbon atom shares 1 electron with 4 hydrogen atoms and forms 4 CH bonds, a methane CH4 molecule is formed. So if it is sharing with the hydrogen, Okay, then which molecule will be formed, students? CH4. Okay, we'll just see the structure. This is the structure. Okay, structure formula and electronic dot model. Okay, so you can see carbon, it has to, how many valency? 4. So how many bonds it will form? Covalent bonds? 4. So you can see here, see, this is your first bond, this is your second bond, third bond, and this is the fourth bond which the carbon has formed with the hydrogen. Okay, and you can see electronic, these are the electrons. Okay, these two are the electrons, so these are the shared one. Carbon, one electron is there, last orbit 4 na, so if this is of carbon, this electron is of hydrogen. If this electron is of carbon, this is of hydrogen. If this electron is of carbon, this will be of hydrogen. So like this they are sharing. So now see, hydrogen has also got 2 electrons in its orbit. Okay, so of course duplet is complete for hydrogen. And carbon, if the last shell, if you see, this is the last shell. Okay, whatever is shown. So see here, 1 2 3 4 5 6 7 8. So here also the last shell carbon is complete now. Octet is complete. So it will become CH4 will become a stable electronic configuration will be there for methane. Okay students, I hope you understood the structure of the methane also. Okay, we'll proceed. Yes, so the next part we are going to see properties of covalent compounds. Now what are these properties of covalent compounds? Covalent compounds have low melting point and boiling point. Okay students, remember this. Generally they are insoluble in water and soluble in organic solvents. Okay, they are not soluble in water, but in organic solvents they dissolve. They are poor conductors of heat and electricity. So covalent compounds are poor conductor. Methane, if we take an example, it is a covalent compound, right? It is the poor conductor of heat and electricity. Okay, now as the methane is formed as a covalent bond. Okay, now we will see saturated and unsaturated hydrocarbons. A carbon atom exhibits a characteristic property. It can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. I told you. The hydrocarbons having only single bonds between carbon atoms are called saturated hydrocarbons. For example, ethane, C2H6, which is, if you have such structure, student, CH3-CH3. Now see, only one bond is there. Okay, or propane, you can see how propane means 3 carbon atoms. Okay, so see, 1 2 and 3 carbon atoms are linked together. Okay, so it is called as a propane. Okay student, so these are called as saturated hydrocarbons because they have only single bond between carbon atoms. Okay, now some hydrocarbons have a multiple bond between 2 carbon atoms. A multiple bond can be double bond or a triple bond. Hydrocarbons having at least one multiple bond are called as unsaturated. Saturated is simply, you will remember student, saturated means single bond, covalent bond between 2 carbon atoms. Unsaturated hydrocarbons means 2 or 3 covalent bonds between the 2 carbon atoms. Okay, so for example, it will become ethene. Now ethane will become ethene. Why? Because CH2 double bond CH2 it has become. Okay student, then you have ethyne. Ethyne means CH triple bond CH. Okay, see here, carbon 3 bonds with other carbon it has formed, and remaining one we have put the hydrogen. 4 we have to show na. So 3 it has done with the other carbon atom bonding, and fourth one will be the hydrogen. Okay students, I hope you understood. Like that you can have propene. As I told you, propane means 3. So propane will change to propene. Okay, when it is a double bond. Okay, and when it's a triple bond is there, then propyne it will become. Okay, see here, they have shown you propyne also. See, can you see CH3-C triple bond CH. With one of the carbon atom, it has formed the 3 bonds, 3 covalent bonds. Okay, so I hope you understood what is saturated. Simple, saturated means 2 carbon atoms, in them you have a single covalent bond. Unsaturated means 2 carbon atoms can have double bonds or they can have a triple bonds. Okay students, I hope till here it's clear to you. Okay, we'll proceed. So today we have studied about, students, we saw the fullerene, that is the last one crystalline form, yes, of the carbon. Yes, then we studied amorphous forms of carbon, you saw, yes, coal, coke, okay, charcoal. And then we saw about the hydrocarbons, saturated and unsaturated carbon. Hydrocarbons, we have seen how the bonds are formed, single bond, double bond and triple bonds, okay, and how the name changes. As we saw, propane means single bond is there, propene double bond, and propyne triple bond between two carbon atoms. Okay, I hope today's part is clear to you. You have understood whatever we have studied today. Okay, go through properly again the video and study, students, properly the video. Okay, so we'll meet in the next presentation with the next part of the chapter. So take care. Sairam.